هيدر هيدر عم الآخر هيدر.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. إن الله وملائكته يصلون على النبي يا أيها الذين آمنوا صلوا عليه وسلموا تسليما. اللهم صل على محمد وآل محمد. Alhamdulillah, we have reached lesson 5 of Introduction to Formal Logic. And before we begin, I'd just like to address a very quick point. So I read a book called Al-Rad al-Mantiqiyya by Ibn Taymiyyah, and Ibn Taymiyyah is someone who is an opponent to quote-unquote Greek logic. Now, one of the points that he brought up in the book was that Greek logic has a very heavy over-reliance on definitions to create non-simple apprehensions. Now, I'm going to explain what his point of view is, and I'm going to explain why I might disagree with that. So now, his point of view is that people can come up with a concept before they come up with a definition. Now, if you've been following my lessons, you'll understand that this is exactly the case. And Ibn Taymiyyah is attacking the point that the Greek logicians rely too much on defining in order to come up with a concept. Now, obviously, we in our lessons have learned that you come up with a concept before you define things. And in order to reconcile this, I want to explain where his thinking was wrong and where what we are thinking and what I'm teaching is correct. So, Ibn Taymiyyah believed, or at least the Greek logicians back at the time, especially among the sophists, they believed that you could only form a concept of a thing by forming a definition about it. Now, obviously, this is not correct. The sophists are incorrect in that regard, and Ibn Taymiyyah is spot on in that criticism. Now, the reason why his criticism isn't really important or valid is because the point of a definition is to signify your apprehension of a concept. So earlier in the first lesson, we discussed two things: apprehension and affirmations. So one of the main things is we understand apprehensions and we understand affirmations. Definitions are signifiers of apprehensions, and what we're discussing now, propositions, are signifiers of affirmations. Now, propositions being signifiers of affirmations and definitions being signifiers of apprehensions means that the signifier can change, and the signifier can be different, and it can be malleable to suit your needs as necessary. The main point, though, however, is that whether or not concepts can be universal. Now, Ibn Taymiyyah, for example, he disagrees and he rejects the grounds of induction, for example. Now, the reason why rejecting induction is wrong is because if Ibn Taymiyyah rejects induction, then he has to reject a proof of God, because it is only possible to form such a proof with induction. Now, that being said, I think that's a pretty good aside. So what we're going to discuss here today is continuing on the previous lesson about propositions. So last class what we went over the basic idea that propositions are a statement of an affirmation. So, for example, if I said the sky is blue, prior to forming the fact that the sky is blue in a sentence, I had to understand that as a concept. Now, I understand that as a concept, I affirm that, and in order to express that affirmation, I make that proposition that the sky is blue. Now, last class I discussed three possibilities of things: necessary, possible, and impossible propositions. Necessary propositions, for example, are red is a color. So red by essence is a color. It falls under the category and circle of colors, for example. If I said a human is an animal, and human falls under the necessary category of animal. These are necessary propositions, meaning that by essence, you are affirming the larger genus of that thing. Possible propositions, for example, are propositions regarding the accidentality of something, meaning that the proposition is in relation to whether or not something can be true. It may or may not be true, but it doesn't relate to the essence at all. It relates to something outside of the essence. Impossible propositions are propositions that have absolutely no relation to each other. So for example, saying my favorite color is Tuesday is an impossible proposition. And the reason for this is because we discussed that all propositions have two properties, three main things. The first concept, the copula that links to the second concept, and the second concept. The first concept and the second concept must necessarily be two things that are either overlapping inside of each other or exactly the same concept. That being said, let's move on to what we're going to discuss today, which is truth tables and propositional properties. So last class we teased over one of the properties of propositions, which is known as distribution. Extension or distribution is is a property of a proposition where if you affirm something for the larger concept, it must necessarily be true for the smaller concept as well. So anything that is included within the larger concept must also possess that property. So if I said all D-block metals possess magnetism, that means that every single one of those metals must also possess magnetism, because I'm talking about the larger concept of D-block metals. So if I said cobalt is a D-block metal, all D-block metals possess magnetism, cobalt must possess magnetism. This is a distributive proposition. Now, today we're going to discuss the basic categories of propositional statements, and we're going to relate them to whether or not they are necessary, possible, or impossible. So all propositions can fall into 5 categories. They are either affirmative, negative, they are if-thens, ands, or ors. Let's go over them one by one. So affirmative propositions are is statements, meaning that the sky is blue, or saying that he is walking. Negative propositions are propositions where you negate the existence of something. So I said the sky is not blue, or he is not walking, are negative propositions. If then is pretty self-explanatory. I'm sure you've gone over it once or twice before, but very quickly, an if then statement is that assuming one condition is true, the next condition must necessarily follow, meaning that if it is a triangle, then the angles add up to 180 degrees. So if you say the angles do not add up to 180 degrees, you can say it is not in a triangle. The next statement is an and statement, meaning that two concepts can both be true. And the last statement is an or concept, meaning that one statement must be true or the other statement must be true. So let's say, for example, an example of an and statement is that the sky can be blue and trees can be green. Those two are mutually exclusive. They can both be true. Now, an or statement, for example, is the sky is either blue or it is not blue. That is a or statement, meaning that it is either one of those two truths. Now let's go over the last of those three, if, then, and or. So regarding if, then statements, let's go over the cases one by one and let's categorize them as necessary, possible, and impossible. So let's start with saying that we have two cases, P and Q. So I'm going to use these letters, P and Q, for the remaining part of this lesson, just to simplify things and make things a little bit easier to talk about. So if P, then Q. That is our statement, right? So Q being true is necessary if P is true. So let's categorize the cases. If P is true, then it is absolutely necessary that Q is true. And if P is Q, it is impossible that Q is not true. However, it is possible that P is true, and it is also possible that P could not be true. Those are possible cases. Now, what do I mean by possible? I mean that it could be either of the two. We can change that around. However, the state of Q is dependent on the state of P, so long as P is affirmed or that P is given truth. Now, we won't say the other way around. We won't say that if Q is true, it must mean that P is true, because if then only works in one direction. However, there's one property of the if then statement known as the contrapositive. So if I say not Q, then I can say not P, meaning that if you have an if-then statement like PQ, and you negated the second part of it, the Q, and you flipped it around, then you can negate the first part. So, for example, if I said the statement, if he opens the door, he will walk in. He did not walk in, therefore he did not open the door. That is a contrapositive statement. Now, in relation to the and statement, there are a couple of cases. P and Q being true is both a possible, P and Q are both possible, meaning that you can change P and Q. And there's no necessary statement that comes out of this. It could be not P, it could be not Q. However, there is no necessary conclusion out of these. If you, however, were to say P and Q, if P and Q, then R, for example, R would be a third case. If you were to say if P and Q, then it is necessary that P and Q be both true. It is necessary that P and Q be both true for R to be true. The existence of an and statement is necessary for syllogisms. In a syllogism, you take one statement, such as all D-block metals possess magnetism, and then you say cobalt is a D-block metal, therefore cobalt possesses magnetism. This is the combination of an and statement and an if-then statement. Let me explain how. So the and statement is that the first premise, all D-block metals possess magnetism, is true, and the second premise, that cobalt is a D-block metal, is also true. Now, if both of these are true, then the third statement is that cobalt also possesses magnetism is also true. Now, and is simply just an operator. We can throw this within an if-then statement, and we can work around with it, and we can use it appropriately. Now, the third statement is the or statement. Now, in an or statement, there are only two cases. So, if I said P or Q, and I said P is true, then Q cannot be true. However, if I said not P, then it is necessary that Q is true. However, if I also said Q is true, then I have to say not P. And if I say Q is not true, then it has to be P. So or statements are very useful for us. And earlier we discussed one very significant or statement, which was the law of non-contradiction, which was last class. And in the law of non-contradiction, what we discussed was that one concept cannot have two separate affirmations tied to it. So the sky can not be both blue and not blue. It's impossible for that to occur. So for an or statement, if P, it is necessary that Q must be false. However, if we said it is possible that it could be P or not P, then that is also, sorry, let me correct that. One of the possible statements of that is that it could be P or it could be not P, or it could be Q or it could be not Q. However, when you do affirm one of those two, it is necessary that the other one must not be true. And an impossible case would be that if you said P or Q and you said P is true and you said Q is also true, that is an impossible statement if those are an or statement. Now let's talk about these in relation to each other. So, for example, when would you use an and statement? An and statement would be used when you're discussing two concepts that overlap, like a Venn diagram, for example. So, for example, when you're talking about two concepts that overlap in a Venn diagram, or if you're talking about two concepts that are within each other. So, for example, I mentioned the syllogism regarding the cobalt being magnetic. So magnetism is a property of cobalt, and cobalt falls within D-block metals. So the and statement being applied here is because cobalt falls within this larger category. However, the or statement is very special because the or statement is only for concepts that must contradict each other. So the sky being blue or not blue is one concept to which I am applying one true statement. It's not the case that I'm saying that either the sky is blue or my house is yellow, because those two are mutually exclusive. So again, with all propositions, I remember last class we said there are three necessary parts to all propositions. The first part is the first concept. The second part is the copula, and the third part is the second concept. Now, the copula must link these two concepts together, meaning that it is impossible to apply any of these if then and or statements to concepts that have nothing to do with each other. So you can't say if this lamp is on, then the universe is flat or something. You can't say that. That's impossible because those two statements have nothing to do with each other. Maybe one of them can be true and the other one can be true, but none of them have anything to do with each other. So when we're using these statements, they all have to at least be within concentric circles of each other in concepts. I think that's all. That should be all for today. Next class, inshallah, we will go over the final bits about propositions and the final bits about syllogisms, and we'll go over properties of syllogisms. And in the next class, inshallah, we'll talk about logical fallacies and learning some basic techniques of argumentation. Wa alaikum assalam wa rahmatullahi wa barakatuh.